better late than never is right. Let's see if we can do this one. This is one we've already done. What are you doing to me, guys? I'm going to find this one. If we go back and have a look. Oh, I think I did it in our content library. And then we did term 1. And when I went through the first sample questions... Oh, it was somewhere. It was very exciting when we did it. I'll just do it again anyway. Yes, you're good. I'm going to restart this one so it doesn't matter. Yes, better late than never is correct. Now, this is one I remember doing it in class, but not everyone was doing it at the same time. Let's have a look and see how we go with this one. This is actually probably the hardest one out of all of the practice questions you were given. So, fair enough if we had a little bit of trouble. So, S1 is the sum of the first one term. So, it's just equal to the first term as well. And that's equal 1 plus k. Now, if we keep reading here, the sums of the sequence are as follows. So, the sum of the first two terms is equal to 5 plus 3k. If I find the difference between this one and the previous one, well, that's how much I had to add on with the second term. So if I want to find, and it says we've got to find u2, u3, and u4, so the second term is just 5 plus 3k. That's the total after two terms. Take away whatever the first term was, 1 plus k. And so we get u2 equals 4 plus 2k. If I want to find the third term, well, the sum after adding all three of them together is 12 plus 7k. So we've got that written over there. So therefore, the third term must be the difference between adding all three terms together, 12 plus 7k, and adding just the first two terms together, which was 5 plus 3k. And you can see how that works. Obviously, that's the sum of the first two. By the time I add on the third one, I end up with that. So the difference between them must have been how much I added on. So that's 7 plus 4k. And the last one, u4, must be the difference between the sum of the first three and the sum of the first four, which they told me was 22 plus 15k. So here I go. The fourth term will be 22 plus 15k. That's the sum of the first four. Take away the sum of the first three, and I'm left with whatever the fourth one was equal to. So here we go, 22 minus 12 is 10, 15k minus 7k is 8k. So if I write the terms out in order, I've got u1 equals 1 plus k, u2 equals 4 plus 2k, u3 is going to be 7 plus 4k, and u4 equals 10 plus 8k. And you can see here we've got two separate sequences. The first one here, the difference between the terms is pretty obvious, isn't it? The difference between terms is we are going up by, I wonder why it makes that disappear when I do that. That's really funny. We're going up by 3 every time. On the other side with the k's, the number of k's is doubling. So the yellow sequence is, of course, an arithmetic sequence, and the blue sequence, highlighted blue there, is a geometric sequence. So if I want to find the general term... Oh, well, I just stopped there. I think the next question then goes on finding what the general term is. We might as well keep doing that. Once I've got this, the general term is just the general term of the arithmetic sequence, which is u1 plus n minus 1 times d. That's the way we usually write it, isn't it? And then let's call the geometric one, and see, it's not really good to write it like that. And this is, anyway, it'll be fine. And this is u1 r to the power of n minus 1. Now, it's probably best if we said let this sequence be a1 dot dot dot, and this be b1, b2, b3, b4. So rather than writing u there, I'm just writing a plus n minus 1d, and here b1 times r to the n minus 1. The reason for that is I've already got u being used for the whole sequence, so I can't therefore say, oh, part of the sequence is u1. That's a little technical thing to worry about. It wouldn't actually affect your results, but it's good if we're doing that in an assignment or a write-up. We'd want to get that right. So here, this sequence started with 1, and we're adding n minus 1 times the difference, which is, of course, 3. We could see the difference between each term was 3 there. And on the right-hand side, the first term was k. Okay, that's good enough. So it's k. And then we're multiplying by 2 to the power of n minus 1. So we can simplify that a little bit. This is 3n. That's going to be minus 3, but plus 1, so that's minus 2. Plus k times 2 to the n minus 1, if you wanted to go ahead and do that. Good question here by Jared. What is k element of z? K is obviously the k they're referring to. The constant is an element of, is what that symbol means. It is an element of the set, if you really want. And z, with it, oh, it's just z, it's not z plus, that was from one of your other questions. Z are the set of integers, so they're the positive and negative whole numbers, or 0. What are the other ones we've got to worry about? R, that's the set of real numbers, so they're all the numbers that appear on your number line. So integers, positive and negative whole numbers, and 0 are the real numbers, all the fractions, all the repeating decimals, non-repeating decimals, etc. All right, I hope that helps. I'm going to get on to the next question because I can see we've got another one waiting for us. Good luck. Don't panic too much. It's just to see how we're going, and we'll be right tomorrow. Cheers, guys.